Let's have a look at an inequality that involves a quadratic expression in the denominator. So we're going to solve the inequality 1 over x squared minus 4x plus 3 less than or equal to negative 1. Now we have the same problem as before, that if it's an inequality and we're not sure what the denominator is in terms of whether it's positive or negative, we don't know whether, by multiplying sort of both sides by the denominator, whether we flip the inequality sign or not. So we're going to sort of switch it around. So what we're going to do first is let's find the values of x that x cannot equal, since you can't have a division by 0. Okay, so what we're going to do first is we're going to solve, okay, x squared minus 4x plus 3 equaling 0, because that's the first thing we'll need to consider. Are there values of x where the fraction results in a division by 0? Okay, and then we have to exclude those, and they're actually two critical points too. So this is the first thing we need to do. Factorizing that, we get x minus 1 and x minus 3 equals 0. Therefore, x equals 1 or 3. So two critical points. Okay. In fact, x cannot equal 1, and also x cannot equal 3. All right. So maybe what we can do is build the solution. I might actually just draw it here. So I've just run out of board space. Put a 3 there, and we might put 1 here. And we're going to put open circles. Now what we're going to do is we're going to solve this inequation as if it were an equation. So we're going to replace the inequality sign with an equal sign. And let's see what happens. Going to solve it as if it equaled negative 1. In fact, it can, because it's less than or equal to. So in one sense, it's actually valid. We're actually finding a value of x where, in fact, the value of the fraction is, in fact, negative 1. So let's see if there's a possible solution to this. Right. Multiply both sides by the denominator, so we get 1 equals negative x squared plus 4x minus 3. And if we move sort of everything over to the other side, we're going to have x squared minus 4x and plus 4 equals 0. Okay, and that's a perfect square, isn't it? So that's the perfect square. X minus 2 all squared is equal to 0. Therefore, x equals 2. And x can in fact equal 2 because the inequality also involves less than or equal to negative 1. So I guess what we do in this case, I mean, it's in fact a closed circle, isn't it? Okay, so I might just put that there. Just draw in this this critical point. So we've actually got 3 critical points, which means that we need to test 4 regions to sort of do this properly, okay, and comprehensively enough that we're not going to miss anything here, because you just don't know what kind of function you're going to get. Now what we're going to do is test these various regions to see if the inequality holds true. Okay, so what we'll do is that let's pick a value first. In fact, we can pick 0 to begin with. Okay, so testing around the critical points. Okay, and the first one that we'll test is x equals 0. Okay, so we are solving for x there. Okay. Okay. And we're just testing to see that it's in fact less than -1. So let's go back to the original fraction there, the original expression. Okay, and good thing about this is you can just replay, just sort of replay the calculation when you need to. So, I'm just going to type it in first. 4 outside of 0 plus 3, and we get 1/3. 1/3 is in fact greater than -1, so that fails. Okay, I'm running out of space here, so I'm not showing the full calculation. So that's false. Okay. Now we're going to test x equals, or x equaling maybe 1.5. Okay. So what we'll do is we'll go back here and we can edit. Okay, there's a couple of ways we can do this. We can also store the value in the memory location, but I might just replace this with 1.5. Okay, the variable 1.5. It's very important to use the brackets as well. Okay, and we get -4 on 3, which is in fact less than -1. So that's in fact true. Okay. Now let's test between 2 and 3. Okay, so go back and change these values from 1.5 now to 2.5. Okay. -4 on 3 again. That's also true. Okay, so x equals 2.5 is also true. And the last one we're going to test is maybe x equals 4. Okay, so and we'll see if that's true or false. Okay. Oops. 4. And that's 1/3, and 1/3 is clearly bigger than -1, so that's false. So going back to our diagram that I originally drew at the beginning. Okay, we've got true here and true there, so that's between 1 and 2 and 2 and 3, but it happens to include 2. It happens to be a closed circle, so because we've included the closed circle in the interval, you actually can ignore the 2. In fact, it doesn't mean anything. So therefore, okay, x must be between 1 and 3, not including obviously the 1 and the 3. Okay, thanks for watching.